Good day to you, students. I'm sure you're fine, and I want to appreciate as many people that are sending their comments, that are sending their assignments, and I mean their classwork. I say thank you. It's a wonderful one, and we are doing our best to correct and to do corrections personally so that they can grow. And it's a wonderful one that you are doing. It's a wonderful work that you are doing there. Good job. Yes, we are still, I told you we are going to be having a long session of trigonometry. Yes, so I told you we are going to be having a very long session of trigonometry. So, and today we want to move to special angles. The special angles we are going to be talking about are just three for now. With time, when we get to a graphical aspect, other ones will just come through naturally. Other ones, when we get to quadrants, all those things, quadrants, so other special angles will just come through like 240, 150. But for now, we are going to be treating angle 30, angle 60, and angle 45 degrees. Angle 30, sorry, angle 60, and angle 45 degrees. We are going to be discussing this. So I want to explain the derivatives of this angle so we can pick up from there. Listen, pay attention to this work. This method, this that I want to teach you, it's something you have to memorize. But if you are not a person who memorizes, then you need this derivative that I want to give to you now. I just could have given you sine 30 is equal to half, sine 60 is equal to root 3 over 2, tan 30 is equal to 1 over root 3, and just cram it. But I know there are a lot of students out there who are not good crammers. Like myself, I'm not very good at cramming. In fact, I struggle with cramming. I just would want to understand. Teach me. Let me understand. Teach me very well. Let me get what you are saying. So I know we have a lot of students like that. So I would want to teach these things so that they would get and put it at the back of even when you are at the point where you are confused of that shape, of confused of sine 30 of cos 45 for instance, you can easily draw the picture and get your perfect answer. That is the importance of this that we are trying to do. So let's go from 30 and 60. So here we are going to be using a diagram for these two and one diagram for this one. So let me go for 30 degrees and 60 degrees first. In this 30 and 60, to get 60 degrees, we can divide 60 into to get 30 degrees, we can divide 60 into 2. So let's start from 60 so that we divide 60 into 2 to get 30. It's easy. Which of the triangles can practically give you 60 degrees? That can easily give you 60 degrees automatically. It's equilateral triangle. Equilateral triangle will easily give you 60 degrees. If you have an equilateral triangle, that means all sides are equal. We have discussed that. So this will be 60, obviously. This will be 60 degrees, obviously. And will be 60 degrees. So if we have all these coming together, then give me any value. Let me say 2, 4, 1, even A, B, any value. So I can bring it there. Let's say 2. I'm bringing 2 here. Obviously, this will be 2. All the sides are equal. This also will be 2. So once I've filled this side, I told you before this class that equilateral triangle you can bisect it into 2 equal halves so that you can have 90 degrees out of it. When we started this topic, I discussed it with you. So if you have this, I can redraw this my shape to be something like this. I will have 60 degrees. This one will be cut into 2. We have 30 degrees. This one will remain to be 60 degrees. This one will still be 2. And here 2 has been divided into 1 1, so this will be 1 now. I hope you are getting what I'm trying to say. So once this is 1, then we can get this side by Pythagoras. So far we have 2 and 1 by Pythagoras. Let's see. So here we have hypotenuse square, that is 2 square, and this side negative now equals what do I call, let's call this one a b c, let's call it ab square now. So we have 4 minus 1 is equal to ab square, so we have 3 is equal to ab square, so we have root the two sides, so our ab is root 3, so we have root 3 here. So if you want to just do this one, just write, give me a right angle triangle, an equilateral triangle, give me 2, give me 2, give me 1 1, give me root 3, this will be 30, this will be 30, this will be 60, this will be 60. So let's start from sine 30 now. Sine is opposite of hypotenuse, you know that. I hope you have crammed that already. So our opposite here is 1 and our hypotenuse is 2. So sine 30 is equal to 1 over 2 or 0.5. So this is automatic from Nigeria to America to Australia. Sine 30 is equal to 1 over 2. So bear that in mind. So our cos 30 is going to be, don't forget, cos is adjacent against hypotenuse. So adjacent here is root 3 and our hypotenuse is 2. So that is that. And our tan 30 now will give us opposite over adjacent, that is TOA. So we have opposite to be 1 and adjacent to be root 3. So let's have this at the back of our mind. This is what it is. So if you go for sine 60 now, sine 60, don't forget sine is opposite over hypotenuse, so we have our opposite here on 60, opposite root 3 over 2, so we have root 3 over 2, and our cos 60 is going to be equal to cos 60, that is adjacent over hypotenuse, that is 1 over 2, 1 over 2, and our tan 60 now, our tan 60, that is opposite over adjacent, that is root 3 over 1, which is as well root 3. You don't have to put over 1 there. So this is what we have, and this is what you should cram. Don't forget that sine 30, looking at this, sine 30 is equal to opposite over, sine 30 will be equal to cos 60, as you can see. Sine 30 will be equal to cos 60, as you can see. Then cos 30 will be equal to sine 60, as you can see. And tan 30 is going to be 1 over tan 60. That is the reciprocal of tan 60. That is the summary of what I have here. That's the summary of what I have here. So let me quickly go through this again. I was able to use equilateral triangle with 60 and 60 and 60. Then I bisected into 2 equal halves, so I have 90 degrees as a perpendicular. So if I have 2 here and I have 2 here, then this will be 2, everything will be 2, that is 1 and 1. So by Pythagoras, I got this one to be root 3. That was what I wrote here, root 3. So from there, opposite over hypotenuse sine, adjacent over hypotenuse cos, opposite over adjacent tan was what we used to get our 30 and 60. I hope you actually understood what I taught you. So before we check this out, like a classwork, let's check 45 immediately. To get 45 degrees, then we should ask ourselves which of the triangles, that would definitely give you 45 degrees automatically. Then I'm looking at a right angle triangle that is as well is an isosceles. I told you that a right angle triangle can as well be isosceles and can as well be scaling. I told you I said it in one of our classes like that. So if I have a right angle triangle that is as well an isosceles, that means I will have this side and this side to be equal. So far this is the hypotenuse, then I will definitely have 45 degrees. That is the base angles being equal, so the sum will be 180 degrees. So if I have any value here, let me call it 1, anything, let me call this one also 1, have any value here, definitely by Pythagoras, that is 1 square plus 1 square will give us 2, and that is going to be, let's say, A and B and C. So my AC now square by Pythagoras will be, then I have AC square. So if I root this, I have AC to be equal to root 2. So I have this one to be root 2. So once we have gotten this, then we can go sine 45 now. That will be opposite. Anyone you choose is the same. Anyone you choose can work. So we have 45, that's opposite to hypotenuse, that's 1 over root 2. If you rationalize this, you have root 2 over 2 here. Then cos 45 will definitely give you 1 over root 2 as well. Check it. Cos 45, that is opposite adjacent to hypotenuse, or root 2 over 2. So, and tan 45 will give you 1 over 1, which is 1. Check it out. So I used right angle triangle that is as well a scaling triangle, so that I can equate this one to be this, and the base angles will be equal. Then with Pythagoras theorem, I was able to get this as my root 2, that is my hypotenuse. Then I was able to solve this. That is